During the anaerobic phase of enhanced biological phosphorus removal, what do PAOs principally do? So you have three tanks. Again, I think I explained this before. First tank is going to be your anaerobic tank. Your second tank is going to be your anoxic tank. And your third tank is going to be your aerobic tank. So we're talking about this tank right here. So what's happening is that the PAOs are going to be releasing P and taking out VFAs. All right, so let's look at the answers. What do PAOs principally do in your anaerobic phase? Are you gonna oxidize ammonia? No, those are going to be your nitrifying bacteria. Are you going to take up phosphate from the water? No, that happens in your aerobic phase. So no. Are you going to be consuming nitrogen gas? No. Are you going to be releasing phosphate while taking up fatty acids? Yes. So that's going to be D. Which grit removal system uses controlled swirling to separate particles primarily by density? So you have uh, three types of grit removal systems. First, you have your velocity control or your horizontal. You're basically going, it's coming in, it's moving about 1 foot per second. Yeah, so then you have your aerated grit, which is going to be diffusers at the bottom. They're going to be releasing air. It's going to create a swirling motion. And then the grit will be too heavy, so it'll fall down or it'll be taken up, depending on what you have. Then this next is going to be your vortex. Your vortex is going to come in. It's basically going to be in this vortex chamber. Your heavy is going to be going to the middle. Your outside is going to be, your water is going to be on the outside. So let's see, uses controlled swirling to separate particles primarily by density. And then C, horizontal flow grit. No, and then a commuter, that's just, think about like a trash disposal in your kitchen, that does nothing but just breaks it all up. So number 27 is going to be vortex chamber. So don't pick aerated. If it's looking for swirling motion and or air, that's going to be your aerated. If it's just swirling motion, that's going to be your vortex. Which functional group performs first oxidation step from ammonia to nitrite? So this is talking about the first step of nitrification. So let's see. We're looking for the functional group that performs oxidation of ammonia. So ammonia oxidizing microorganisms is going to be the answer. Nitrifiers convert nitrate to nitrogen gas. Nitrite oxidizing bacteria uh, nitrify nitrite to nitrate, so it's not going to be that one. So it's going to be a ammonia oxidizing bacteria. A standard centrifugal pump curve principally shows the relationship between, let's see, is it going to be A, head and flow rate? Is it going to be B, diameter and velocity? Is it going to be C, motor speed and line voltage? Or is it going to be D, water temp and density? It's going to be A, the head and flow rate. Which microbial group converts propionic acid, butyric acid, and similar intermediates towards acetate and hydrogen? So you have acetate, you have hydrogen, and the answers are going to be A, acetogenic acid, B, methanogen, C, nitrifiers, or D, PAOs. It's going to be acetogenic because you're converting this, the all these acids into hydrogen and acetate, so acetogenic. bacteria. Which configuration uses 5 biological stages to achieve very low nitrogen and phosphorus concentrations? So, is it going to be a 5-stage Bardenpho? Yes. Is it going to be an MLE? No. Conventional feed step? No. And a single stage oxidation? No. What is the primary risk if the discharge valve is closed while a positive displacement pump is operating? So, a positive displacement pump basically does this. It takes a one, say, let's just say every stroke, it pumps a gallon, right? So, it'll pump a gallon and then it'll discharge a gallon. So, if it's pumping a gallon and you're discharging a gallon and you close the discharge valve, what is it going to do? It's going to blow up. So, what is the answer to the question? Is it A, the pump automatically enters bypass? No. Is it B, pump or piping failure from overpressure? Yes. If you're pumping, if a gallon's coming in and a gallon's coming out, and you close the end, that gallon's still going to come in. So it's going to either explode the pump or explode the pipe, whatever is the path of least resistance. Is it going to be C, the motor accelerates without limit, or is it D, flow decreases harmlessly? No. So the answer is going to be B, pump or piping failure from overpressure. All right, number 33 says approximately how much alkalinity expressed as calcium carbonate is consumed per unit mass of ammonia nitrogen nitrified. Is it A, 8.3? Is it B, 7.14? Is it C, 4.57? Or is it D, 3.57 units? So the answer to number 33 is going to be B, 7.14. So what this is saying is this. Let's see. Let me read it right quick. So ammonia nitrified, right? So it says if 1 unit of ammonia is nitrified, then you're going to need 7.14 units of calcium carbonate. Now that's happening in your aerobic tank. Now when it goes from your aerobic tank right here and gets returned in your IMLR line, your internal mixed liquid recycle line, then it's going to denitrify. So it's going to go from your nitrate to nitrogen gas. And that's going to return approximately half, which is about 3.57 for denitrification. So for full nitrification, you're going to need 7.14 of calcium carbonate. All right, number 34. What is the primary operating advantage of an aerated grit chamber over a horizontal flow pattern? Is it A, it removes dissolved solids by air stripping? Is it B, airflow provides stable control for keeping organics suspended? Is it C, it eliminates downstream disinfection? Or is it D, it requires no energy input? So it's going to be B, airflow provides adjustable control for keeping organics suspended. If you if you don't put enough air in there, then you're going to get solids in your grit line. If you put too much, then you're going to have grit in your primary solids line, and it's going to be discharged to your primaries. Now you're going to have too much grit in your primary solids. So why wouldn't it be number A? It removes dissolved solids by air stripping. That doesn't happen. You can't just get rid of solids by adding air. It eliminates downstream disinfection? No. Does it? It requires no energy input. Aerated grit is probably the most energy intensive. Which range is a reasonable broad screening value for volatile solids reduction in a municipal digester? Is it A, 35 to 60, B, 75 to 80, C, 85 to 95, or D, 10 to 20%. The answer is number A. It's going to be 35 to 60%. What is the primary function of a lantern ring in a packed stuffing box? Is it A, catch leakage before it reaches the motor? No. Is it B, prevents all shaft vibration? No. Is it C, distribute seal water for cooling, lubrication, and air exclusion? Yes. And then is it D, compress packing against the shaft? No. Number 37. What happens when volatile fatty acids rise rapidly without a corresponding increase in alkalinity? So, is it A, pH rises? No. If pH is rising, that means it's becoming basic, but your volatile fatty acids are rising, so it's going to start becoming acidic. So, no. Is it B, buffers consume, pH may fall, and methane production may be inhibited? Yes. So, if your buffer or calcium carbonate is being consumed, then your pH will fall. Again, you're adding acids. And if it's too acidic, those methanogens can't live in there because they like a little bit of a base environment. So it's going to be B. Methane production will always increase. No. And alkalinity automatically rises in equal proportion. No. If you're adding acids and you're not increasing alkalinity, it's going to eat up that buffer. So your alkalinity will not automatically rise. You'll either have to add something to it or whatever. So number 38 says, which device shreds large debris without removing it from the waste water flow? Is it A, bar screens? No, bar screens remove debris and it doesn't shred. Is it partial flume? No, that's used to measure flow. Is it grit classifier? No, that removes grit. And then you have the comminutor. The comminutor, again, is just like a shredder. So it's going to be D. It shreds it, but it continues flowing downstream. Which mineral scale contains magnesium, ammonium, and phosphate? Is it A? No. Is it B, Vivianite? No. Is it Struvite? Yes, Struvite is just almost like concrete. It's bad news unless you can recover it through resource recovery, and then you can sell it as a fertilizer because it is phosphorus. Or is it D, calcium carbonate? No. So the answer was Struvite. How does cold wastewater generally affect nitrification? Is it A, it accelerates ammonia oxidation? No. If you're going down in temperature, having it be cold, those uh, nitrifiers are going to slow down. And it brings us to our answer, which is going to be B. It slows nitrifier growth and it can increase effluent ammonia. If nitrifiers aren't oxidizing ammonia, then your effluent, if it's not breaking down ammonia, then your effluent is going to have higher ammonia. And that's going to mess you up when it comes to your disinfection. C, eliminates toxicity risks. No. Is it D, eliminates the need for a Anoxic zone? No. Your Anoxic zone, when it comes to nitrification and denitrification, only denitrifies. It doesn't break down ammonia. Before starting a centrifugal pump located above the water source, what must usually be done? Is it A, close every valve? No. Is it B, prime the suction line? Yes, it is a centrifugal pump. It needs water in there to sling water to increase the pressure and then to move water. So you need it to be primed. All right, what is the primary purpose of a preliminary treatment in a wastewater treatment plant? All right, is it A, to achieve significant reduction in effluent phosphorus? No. Is it B, to settle out most volatile organics? No. Is it C, to protect downstream equipment and improve process efficiency? Yes. Really, every single system, if you look what's downstream of it, it just protects that system. So a preliminary system basically protects every system. So you don't want a car coming through. You don't want metal coming through. You don't want things that can either settle out in your primaries that will potentially ruin it, or will ruin pumps as well. So, and it's not D to remove dissolved organic matter biologically. That is your BNR and secondaries. What is the primary purpose of the internal mixed liquid recycle in a pre-anoxic BNR process? Is it A, to increase DO? No, it's pre-anoxic. Is it B, to return clarifier sludge? No. Is it C, to add influent carbon to the aerobic zone? No. Is it D, to remove nitrate rich mixed liquor from the aerobic zone to the anoxic zone? Yes. You want to keep those bugs in there. Why is a minimum wastewater force main velocity commonly maintained? Is it A, to scour the pipe and limit solids deposition? Yes. Is it B, to prevent pipe failure? No. Is it C, to force the motor to run faster? No. Is it D, to maximize dissolved oxygen? No. So the answer is going to be number A, letter A. Which change is especially likely to inhibit methanogens and destabilize an anaerobic digester? Is it, let's see, is it A, increase in detention time? No. Is it B, a sudden decrease in temperature? Yes. Yay. Is it C, stable trace nutrient supply? No. Is it a consistent loading within design? No. Let's see. But if you do increase feed too fast, that'll definitely increase your VFAs and then decrease your methanogenic activity. So, number 46, an operator observes rising sludge and small gas bubbles in the secondary clarifier blanket. What is likely the biological cause? Okay, so if you have your clarifier and you start seeing bubbling, that's going to take up this sludge and bring it to the top, making it float. That is likely from denitrification. So the answer is going to be A. What is the principal function of a secondary digester in a conventional two-stage arrangement? So let's see. Number 47. So is it A, rapid acid generation? No. Is it quiescent settling, supernatant separation, and stabilized solid storage? Yes. Is it B, C, primary screening? No. Is it D, intensive aerobic nitrification? No. So B, which environmental condition supports denitrification in an anoxic zone? So is it going to be uh, pH below 5? No. Is it going to be very low dissolved oxygen with nitrate available? Again, yes. What is the purpose of wear rings inside a centrifugal pump? Is it A, uh, provide a replaceable close clearance surface between the impeller and the casing? Yes. You want something that's replaceable. You want something that's cheap, that's made to break instead of uh, messing with or wearing down that impeller or that casing. So it's going to be A. Is it to prevent all pump vibration? No. Is it C, to increase head beyond the impeller design? No. Is it D, to seal the shaft from external leakage? No. So the answer is going to be A. Provide a replaceable closed clearance surface between the impeller and the casing. What normally happens to pH when ferric chloride is added for chemical phosphorus removal? Is it A, it rises sharply? No. Is it B, it remains fixed? No. Is it C, it tends to decrease because acidity and precipitation consume alkalinity? Yes. So pH decreases and it turns sort of acidic, slightly acidic.